Hi everyone, let's solve today's daily challenge, that is construct binary tree from inorder and postorder traversal. So here we are given inorder and postorder traversals of a binary tree and we need to construct the binary tree using these traversals, right? So now first let's see what inorder and postorder is. So in inorder traversal, how do we traverse the tree? So we traverse the tree in, we take the left, the root and the right part of the tree. Correct. So this is the way that we do inorder traversal, and in post order we take left, right and then the root. Correct. So these are the traversals. This is the way that we traverse in order and post order. Now you see in the post order traversal, the root is located at the last. Correct. So if you go and check the post order traversal of any tree, the last index, whatever value is at the last index in the post order traversal, that will be your root. Correct. So here you can see also, like they have already constructed a tree for you here, like for this particular inorder and post order traversal. This is what the tree will look like. I don't know what I made out of my arrow. Let me draw it again. So yeah, okay. So you can see that 3 is our root here, right? Now what inorder does? Inorder takes the left part, the root and the right. Correct. Now we know that the root of the tree is 3, right? So if we go in our inorder traversal, we will locate this particular root to get what is at the left of the tree, what is in the left part of the tree and what is in the right part of the tree. So here you can see that 3 was the root. So in this inorder array, let me increase its size. Okay. Let's rub all this. Okay, so 3 was the root and here we are finding that 3 is present here. That means whatever is left to 3 are the nodes that are present in the left subtree, and whatever is present to the right is to the root node is in the right subtree. Correct. So we can say that this is our left subtree and this is our right subtree. Correct. Absolutely correct. Right. So here you can see also in the diagram that 15, 20 and 7, these nodes are present in the right subtree and 9 is the present in the left subtree, and that is what we have got using the inorder also, right? Now, so now you can say that, okay, so now we have 9 here and here what we will have 15, 20 and 7, right? So can I say, now see, this has become one part of the tree and this has become one part of the tree. So can I, use recursion here, right? So what we will do, we will recursively call for this particular node and this particular tree, correct? So out of this is a fresh tree for us, right? This is the inorder traversal for the right part of the tree and this is the inorder traversal for the left part of the tree, right? So what we will do, we will make 2 calls, one for the left part and one for the right part. So we can recursively solve this. Now let's see, now comes the tricky part in this question, that is how do we know what will be the root, right? So here in the post order we saw that, okay, 3, whatever is present in the last will be the root. Now what? Now see, one thing is for sure, because post order is left, right and root, right? So you have right here, correct, and left here, right, and we have the root. So we remove the root. Now what are we left with? We are left with 9, 15, 7 and 20. So one thing that you can see here is clearly that 20 is going to be the root of the right subtree, right? Because we have the left traversal here and we have the right traversal here and we had the root, so we removed the root. So here we don't know at what position we have to break it, right? But we surely know that whatever is present to the last is our root, and root of what? Right subtree, correct? See, so now we know that this will be the root of the right subtree. So what we will do is we will make a recursive call to the right subtree first. right? And after we are done with the right subtree, right, what will happen? We will be left with the left subtree. So when we will be left with the left subtree, what we can do? So we will, from there, we will know that, okay, we are only left with the left subtree. Here what will happen is, see, this is the right subtree. We can see here clearly, right? This is 15, 20 and 7 are present in the right subtree. So I have just, you can see here that 15, 7 and 20 are in the right subtree. Now after we have, we are done for the right subtree, what we are left with? We are left with the left subtree. Now again, this is the post order for left subtree. So what happens in post order? Whatever is whatever is present in the last in the post order traversal is the root, correct? So we can know that this particular element is going to be the root of the, let's say we had, something like we had more nodes here. Let's say 3, 9 and sorry, 6, 3, 9. We had something like this, and here we had 15, 7 and 20, correct? So we have done for this, right? So these nodes will be vanished and we will be left with this. So when we will be left with this, so we can know that this particular 9 is going to be our root node, right? So I hope this is clear to you. So see, what we are going to do is, now let's clearly, again see what the algorithm is. See, okay, so I'll write it here, right? So first thing is getting the root. How are we going to get the root? Using post order traversal. So we'll get the root using post order. Whatever is present in the last will be a root. Now here there are two cases. First is that, see, for the right subtree, if if you decrement one element, correct, from the post order, whatever value is here, right, that is going to be the root of the right subtree. So what you will do, after you remove this particular root here, when you make the recursive calls, you will make the recursive call to the right subtree first. Let me write here only. Make recursive call to the right subtree. Now what will happen? We will use up all the values, right, in the right subtree. So what will happen? So we will be using a root index, right? We will be using an integer called root index. So that will be, pointing to the last element of each, of the post order traversal, correct? So here we will be at 20, and after this 20, what will happen? We will consume all these values, right? Because we have made the recursive call to the right subtree. So what will happen? We will be making all the, first what you will do, you will make recursive call to 15, 20 and 7. What will happen here? You will have 20 here, correct? So it will construct the whole right subtree, and what you will end up with is the pointer landing to the left subtree, correct? The last element of the left subtree in post order traversal. So that last element becomes our root of the left subtree, right? First make recursive call to the right subtree, and after that make recursive call to the left subtree. Let's just write left here, correct? So I hope like after we will see this in code, we will understand better, right? So see, what we are doing from post order is getting the root. So how are we getting the root? For the left subtree and the right subtree, we just saw, right? And second of all is in order, right? See, to get the left and the right subtree, we have to use in order traversal. So when we use in order traversal, we have to, get the root, and we have to locate its value inside of the in order traversal. So what we will do for that is, we will be taking a map. Inside of this map, we will be putting, this map will store the index of each and every node, correct? So that we know from where we have to break and up to where we have to break, right? So initially what we will do, this map will store index of each node of the tree. And why are we using a map? Sorry. Okay, so we are using a map. So why are we using the map? To get a breakpoint, right? To get a breakpoint for the left subtree and to the right subtree, so that we can locate these particular trees, correct? So this is all that we will be doing. So let's see the code, so things will be more clear to you. See here, what we are doing is, first of all, inside of this function, we have taken a map, and we have put all the values of the nodes, and we have like associated all these values to the index of the particular of that particular node, correct? So like we have, see here you have 3 here, correct, located at this particular index, that is one index. So from this we know that the breakpoint is like from the start index, right, from the start of this in order array up to like 1 minus, let's call it p here. So from 0 to p minus 1 we have the left subtree, and from p plus 1 to the last of the index, right, let's call it end, right? So from p to end, right, p plus 1 to end is the right subtree. So that is why we are keeping these indexes in the inside of the map, right? So after this is done, here we have just taken the size of this. So see, now what is this n? So this n is actually the root index. So the root index is present where? Initially it is in the last of the post order, correct? So that is what I have taken here. I have taken the post order, whatever size is of the array, and minus 1 is where our root index is currently located. Now we are making a call for this helper function. So this helper function will build the tree for us, right? So let's see what this helper function does. So see, first of all, we are passing the post order. We don't need to pass the in order because we are already passing the map. So the in order traversal we are only utilizing to locate that breakpoint, correct? To know where the left subtree is lying and where the right subtree is lying. So we are not utilizing any values inside of the in order or doing anything with in order traversal. We have to just access that breakpoint. So for that we can easily pass the map. So we don't need to pass in order traversal here. So we are passing the post order, we are passing the map, and we are passing this root index. See, this root index has been passed by reference. So why? Because see, we know one thing for sure, that when we have accessed this particular root, right, when we will decrement this particular value, right, by 1, we will be landing at 20. So what is 20? 20 is the root node for the right subtree. That is like, we know that for sure, correct? So for that we are passing this by reference, so that once we build, so that is why we are making a recursive call to the right subtree first to locate where the root of the left subtree is, right? So once we make the call to the right subtree, right, and because this root index has been passed by reference, it will contain, like after the right subtree is built, it will contain the root of the left subtree, right? So that is why we are passing it by reference here. And int start and int end is basically to locate from like where we have to cut the tree, right, cut the array, right? So now let's see. So this will be the base condition, like if for any recursive call this start becomes greater than end, then definitely we cannot do anything. So for in that case we have to return null. Now here, see, here we are getting the root. So the root we will get from root index. So see, we passed n here, right? So this n contains the last element, right? Now we will do minus minus. So now it will contain one element before, right? So it will contain now n minus 1. So what is located at n minus 1? We just saw the root of the right subtree. For this case it was 20. So we are accessing the root of the right subtree. So inside of this we have the root of the right subtree. Then we have taken the index, that is, this is the breakpoint, and here we are creating the node. Now here we are making recursive calls to the right subtree and the left subtree. So we saw that to locate the root index for the left subtree, we need to, build the right subtree first. So first what we are doing, we are building the right subtree. So what we have passed the post order, the map, because we need to get know the breakpoint, correct? Then the root index, which is in this case is n minus 1 for now, and then this index plus 1 to end. So we saw for the right subtree, this p is our breakpoint. So our right subtree is p plus 1 up to end, correct? So that is what we have passed here. So we have told it that this is the new array, this is the new post order or in order, and you have to build a tree out of this now. And then after we are done with this right recursive call, what will happen? Our root index will get updated to the root of the left subtree, that is 9 in this case. So we can easily pass this root index here only, and we can build for the left subtree, correct? And then we have simply returned the root node. So this is basically how you have to solve this question. So in this question, the only tricky part was to locate the root of the left subtree and the right subtree, right? Because we know that we definitely saw that it can be solved using recursion, because what are we doing? We are just having some post order traversal and in order traversal. So we just want to know what are the breakpoints and where we have to, locate the root in the post order traversal. So that was the only tricky part. So here we are, by passing this by reference, we are easily able to, access, like after we build the right subtree, we can easily access the root for the left subtree, because we definitely know in the post order, the root will always be located in the last index of that particular array, correct? So if we see the time complexity and space complexity for this code, so the time complexity is going to be O of n only, and the space complexity will be O of n, because we are using this particular map here, and we will be storing all the values inside of in order traversal. So both time complexity and space complexity for this solution is O of n each. So that is basically how you solve this question. Thank you.